Welcome back to what I'm going to call the tuner extravaganza. So, if you listen, yes, you are hearing a 400 hertz nice clear tone. There is the 400 hertz output of the tuner, and we have deflection on the signal strength meter, and we're tuned to 90.1 megahertz. And as you can hear, I can tune off of it. I'm getting it all over the place. So what does this all mean? Well, don't get too excited yet. Let me turn this down. So I've had a little bit of extra time to play with this, actually just a couple hours the other day, and I went through and verified that at 90.1, and several of these I spot checked, I went through and verified that when I'm on this frequency here, then I am actually getting 0111011, and that would be these transistors down here. So 4.8 volts, or roughly 5 volts, is a 1, and roughly 0 volts is a 0, and this thing tracks all the way across the dial now. So if I go to here, this is what I get. If I go to here, this is what I get. If I go here, this is what I get. So we know that the encoder is working, and we know that it is passing the proper data to that PLL chip. We are still not getting lock, number one, and number two, we are not getting our local oscillator frequency. So according to this 90.1 megahertz, we need to have 100.8. Now why 100.8? Well, any of you who are into FM know that if your carrier frequency is this frequency, your local oscillator is going to be 10.7 megahertz roughly higher. So if you take 90.1 plus 10.7 is 100.8. Okay, so it's a wee little bit off there, but again, you're going to be about 10.7 megahertz higher. That is where our problem is. Our local oscillator is not working. So if you recall from an earlier video, you go through the process of putting this little calibration jig in there, and if you look at the calibration jig, where are we at? Not on this page, hold on, over here, right here, and you inject an 8 volt and a 17 volt signal into this pin 8, and then you adjust that voltage controlled oscillator, which is your local oscillator, to put out these two very specific frequencies. At 8 volts it should be 97.5, and at 17 volts it should be 110.5. That all works perfectly now. I did replace this dual gate MOSFET right here, and it did change it a little bit, and it does work much better, but allows me to get this. However, what I'm not getting is when I disconnect this test jig and I go back to our original synthesizer board, the synthesizer board is not creating the proper voltage for the local oscillator, for the VCO. So what's happening is, even though these codes are correct, the voltage that I'm getting into the local oscillator is incorrect, so it's making my local oscillator voltage incorrect, so I'm not getting 10.7 megahertz. And so since our IF section from here back has to be 10.7 megahertz, obviously it's not going to work. That's our problem. So it's this synthesizer board, and unfortunately it's most likely going to be either one of these chips or something that's failed, and This TC9100 is a very difficult chip to find. I do think that NTE may possibly make a replacement chip, and there's some other numbered ones that have the same pinout that I believe will work, but I'm going to have to research it a little more. And I was able to unequivocally verify that this section is now working properly with those 2 new transistors. This does work, and yes, I don't know how by the service manual you can actually follow that, because even in a perfectly working version of one of these, you really cannot use a frequency counter on pin 20. It will absolutely not read 110.8 megahertz on here, or 122.8, whatever that was supposed to be. Absolutely, positively will not. There's too many harmonics that wreak havoc on your frequency counter, and unless you're going to use some sort of a narrow band filter before your frequency counter, the harmonics the frequency counter goes crazy. So you have to use a spectrum analyzer to set that. And believe it or not, when you do, this is working the same way as a perfectly working model. So that's where we're at right now, and really until I can either get another one of these boards or get all of the proper components to rebuild this board, we're kind of at the standstill. And at least we know now that the rest of the tuner works, with the exception of the synthesizer board. And of course, all I did to make this 90.1 work was I went to this oscillator adjustment, which is the oscillator adjustment consists of this coil and this trimmer capacitor. Remember, we replaced that trimmer because it was bad. And if I adjust this coil to drag the local oscillator into that 10.7 difference, everything works. The problem is, as soon as I change the channel, I don't have 10.7 difference from my carrier frequency, so it won't work that way. And of course, I threw this grossly out of alignment, so I'll have to hook up that jig and do the alignment again to bring it back before I can do this. So that's where we are. So now let's see one of the other reasons that I know what's going on with this thing. Okay, sorry that first clip was a little bit probably bad sounding because I forgot to plug in my external mic, so you were hearing me through the camera mic. But anyways, so you can see from what's before you here that now you understand why I called this the tuner extravaganza. No, your eyes are not deceiving you. There are two, count them, two F28s, and yes, an even more rare F26. Thanks to a very kind viewer who had these, who's an avid collector, and was so kind as to share these with all of us to be able to take a look at them. Now, here's the one that we've been working on right now, and here is the one that he sent us, and it is absolutely pristine. It is like brand new. What I will say is this one works fabulous, and I was able to get inside and take some measurements, and surprisingly, all of the things that I figured out on my own, they're set right. So really the problem that we're down to is that synthesizer board, and that's going to be a little bit difficult, I think, to figure out. But nevertheless, when I get the time, I'm pretty swamped with other projects that I really have to do, and this was going to take up too much extra time, so I'll have to come back to it. But I thought in the meantime, we'd have a little bit of fun on this video and check these out. This particular one up here, and yes, spoiler alert, I did test them, and this is a good receiver. I would say this F28 is every bit as good as the TX 9800s, but I'm not sure if it's better. It might be in some aspects because I really didn't test it scientifically. This is another animal though. all I can say is they hit the nail on the head when they designed this one. It's fantastic. It works. You can literally tell the difference in how it tunes, and you know, all the hype about this, hey, I endorse it now. It's everything they say it is, it is. Now this one's a little bit cruddy, but it works like brand new. It works perfectly. It will need cleaned up, and I think the owner's going to have me go over the whole thing and clean it. I'm not going to align it. It doesn't need it, and I think I do have some service documents coming on this, but I'm probably not going to need them, as this thing is working very, very well. So really just a cleaning job and going over the whole thing, testing it out. We may get into recapping it. I don't know. It definitely, something this old always will benefit from a recap, just for safety reasons, so that, you know, we don't have any caps breaking down and leaking and, you know, causing problems, corroding the board or shorting out and damaging circuitry. So it would probably be worth doing that. And I can imagine that's what we're going to end up doing. But yep, here they are. So let's check these out and just kind of see what they do. All right, we're going to start out with a little experiment. And this is kind of related. There's twofold why we're doing this. First of all, I want to really demonstrate how absolutely phenomenal this signal strength meter is on these. I've never seen a signal strength meter this accurate in my life on just a normal FM broadcast receiver. Now, you would come to expect that kind of accuracy maybe on a ham radio, or a commercial transceiver or something, but it's rare that you see this on this kind of thing. And second of all, everybody keeps asking again and again, what about impedance matching and so forth. So let's do a little experiment to kind of see what we are dealing with impedance matching between our signal generator and our receiver. Now, these receivers have two inputs for your antenna, and one is for 75 ohms and the other one is for 300 ohms. And for 300 ohms, of course, you need to have, a matching balun, kind of like these, that converts the 75 ohms to a 300 ohm balanced. Okay, so we're plugging straight into the 75 ohm input, which is what you'd use normal 75 ohm coax cable. And I'm going to show you a little gizmo here. And what this is an impedance matching pad. And there's all kinds of different ones, and I'll kind of show you a few for different purposes. And you can see there's all kinds of different ones that you can get into. They all look like this, but they all have different properties to them. The frequencies that they work at and the impedances that they go from and to. And this one converts a 50 ohm load to a 75 ohm load. And it's accurate from DC all the way up to 2 gigahertz or 2000 megahertz. And really what this does is it presents it takes this 75 ohm load on the receiver end and makes it appear as a 50 ohm load on this end. Now, nothing's perfect in nature, as we know, and there is a trade-off for having this, and that is that there is going to be a set loss in here. But the good news about that loss is that loss is going to be consistent all across the whole frequency spectrum from DC to 2000 megahertz. So basically all we have to do is subtract that loss, which in this case is going to be roughly 10 dB. So it's always going to be off by 10 dB no matter what frequency and what amplitude we're at. Okay, so, and it'll track pretty close to that. Now the other factor that comes in that affects it is your cable. Now this is a 50 ohm cable, it's also a longer cable. It's probably about 5 or 6 feet long. And this is going to have a reactive component to it. And therefore, as we change our amplitude and frequency, this is going to have a little bit of effect on that drop also. But by having this, it's going to minimize it. Now, the first thing we're going to do is we're going to look at how this works without any impedance matching. And I think you're going to be surprised what you're going to find. So I have this connected up, and I have a 20 dB signal going in here right now. Okay, so, and if you look, it's really not really giving us 20 dB. And you can see up here, I'm going on dBF because this meter reads in dBF. So I'm at 90.1 megahertz, and I have my 20 dBF. All right. So as you can see, currently it's only reading about 10 or 11 dBF. And if we increase our amplitude, so here's 30, and you can see 30 goes a little bit above 20. So 40 decibels, 40 dB is reading about 35. So now it's getting closer to being accurate. 50 dB, it's just a little bit below. Now it's about 47 dB, so it's very close. 60 is right on 60 dB. 70 is right just a little under 70. And now as we get a little bit more, we're going to kind of see, we're going to overcome the properties of this cable a little better. 80 dB, you're now reading about 78. 90, we're right a little bit above 90. All right, and this meter really doesn't read between 90 and 100 very accurately. But you can see this is actually very closely aligned. Very surprising. This is a perfectly aligned receiver. So now let's go back, and we're going to go back to 20 dB, dBF that is, okay? I keep saying dB, don't get that mistaken, it's dBF. It's dB with reference to 1 femtowatt. Very important. You got to keep the units straight in this too. Okay, so we're going to just plug this in now. Okay, just put this little adapter in here. And remember, this is going to have an insertion loss. So that means it's going to absorb 10 dB, 10 dBF all the way across the board. So we have to, there we go. So now we're going to have to add 10 dB to whatever we're reading on this to actually know what's actually going in there. So that being said, if I go to 30 dB, 30 dBF, it's just a little bit under 20, you can see there. If I go to 40 dBF, right about 30 dBF. If I go to 50 dBF, right on 40 dBF. You can see it's tracking right around that 10 to 11 dBF negative. 60 is 50. 70 is 60. 80 is 70, just a little bit above. 90 is 80, right on the button. And 100 is reading right on the 90 line. So you can see this meter is very, very accurate. And the little tiny discrepancies you're seeing, again, is kind of, you have this cable and so forth. But you can see right around that same loss of somewhere around 9 or 10 dBF across the board. And so you can see by putting that impedance matching device in there, you have to keep in your mind that there's that loss. But it's always going to be the same amount of loss as long as it's in some form of decibel or dB. So there you have it. Again, the trade-off is it works linearly. The only thing is if you're trying to work with straight, volts or millivolts or microvolts, you have to do a little bit of a math formula. But if you're doing in units of dB, dBf, dBm, something like that, it will always be that same amount of attenuation all the way across the board. So I hope that kind of gives you an idea of how an impedance matching device works. There's other ways to do it, like using that little T circuit or things like that, but those are very limited bandwidth. In other words, there are more accurate impedance matching devices you could build, and they have very, very low loss, almost negligible loss, but the trade-off for those is they will only work in a narrow frequency band, whereas these ones, they give you one amount of loss, but it is a known amount, and it's that known amount all the way across the board. Okay, another phone, till the next phone call. So as you can see, that's how it works. So you just have to remember to set your signal generator to the amount that you want into the receiver plus the loss. So if you want to actually put that 20 dBf in there, and you know that you have a 10 dBf loss in your impedance matching device, then you would want to set your signal generator to 30 dBf. And then you can see 30 dBf. And down here, the meter's pretty close to 20 dBf. And you can see we're not locked. But if we go up a little bit in amplitude, once we hit about 30 dBf, now there's enough signal for that phase lock loop circuit to lock onto the channel. So now we have a lock. So even on a tiny little 30 dBf signal, we can actually get a lock on this, which is pretty daggone good, I would say. So, and right now all we're using is just a carrier. There's no modulation at all. It's just a straight sine wave carrier signal, RF carrier signal that we're putting in there. So, hope that was a little bit interesting to you. It's definitely interesting to me. So now let's look at what kind of performance this thing can do. Well guys, so here it is. Probably one of the rarest receivers you're going to see on any video. And this is an F26. And by the way, that F28 that we were just looking at, it was the newer model from the first one. So you remember we had the one we did all the work on. It was an early generation. The one you just listened to was the later generation, and those little modifications that we saw scribbled on the schematics, those were actually implemented in that version that we just listened to. So it had those upgrades. Now I put those upgrades in on the old one there, and they do work. So if we do get that synthesizer board working, we will have a second fully functional F28. But if you look at this one, it really doesn't look like much. This receiver kind of leads you to believe that it's actually a cheap receiver. You have an on-off switch, you have a muting switch, and you have your tuning dial, and that's all you have. There's nothing else in here, nothing to it. Funny enough though, this little thin receiver weighs as much as that F28, even though it's half the height. It's very heavy. So it's not very interesting looking on the front. And you're going to find out the way this thing works is very similar to the TX 9800 that we did a video on some time ago, about a year ago. And other than, instead of having a meter, it just has these three lights. which these became very common in the 1980s. Like even the lower end Kenwood receivers, like the KR710, great receiver, by the way, guys. It was one of my first receivers that I bought brand new that I could afford. It had these 3 tuning lights like this. But anyhow, you can see this does have wide and narrow IF, but it automatically knows when to turn the wideband on and when to turn the wideband off based on signal strength. It automatically goes in and out of stereo. It shows you when the PLL is locked. And it has the touch sensitive knob, much like the TX9800 that we did. But the real interesting part is the back of the receiver, and we'll look at that here in a second. Okay, so here's the rear of the tuner, and you can see that there's a lot going on back here. And the first thing that we'll look at is you'll notice on to the left you have an actual, this is all metal ground, where you can actually ground this thing to an earth ground. It has your FM de-emphasis, just like you do on the F28. And in case you guys don't know, in the United States, we use 70 microseconds, and overseas, we use 25 microseconds. And really what this is at what point in time we're putting, in other words, we have pre-emphasis put on a station before it's broadcast, which means certain frequencies are boosted up, and the frequencies and at what dB they boost those frequencies are different between the United States and Europe. So if you did, it won't hurt if you set this to either one. It's just that if you don't have the correct de-emphasis, you won't get as flat of a response curve. This will actually give you a little bit, I would say, kind of a tinnier, more brashy sound in the United States. And if you put this in Europe on 75, it would be a little more, kind of a little more muffled sound, a little warmer sound, I guess. But that's what that's for, in case you guys didn't know. You can look it up. Just look up FM pre-emphasis and FM de-emphasis online. I'm sure even Wikipedia and all those sites will talk about it. The other thing you'll notice is these are gold contacts. Unlike the chrome ones, these ones are gold plated. They're a little bit cruddy right now and need cleaned, but even the antenna terminals, as you can see, have that gold plating on them. And it has your 75 ohm unbalanced. It has 75 ohms where you can clamp the actual shielded cable coax in here and then put the center conductor into here and tighten it down. And then it also has a 300 ohm balanced, where you can use one of those little ballons, once again, like we were looking at, and connect that in there. This has a multipath output. Now, Pioneer, I believe, actually made a scope, and it was kind of a type of oscilloscope, vertical and horizontal, where you can actually view the multipath distortion. And with this, if you look on one of my videos that I did on FM receivers and stereo and all that, I talk a little bit more about what multipath is. And basically this is going to be something that if you use it, it's going to allow you to adjust your antenna to the optimal position to minimize the multipath distortion that you're going to get, or multipath interference you're going to get from the channel. And again, you can look multipath up as to what it is. Okay. You have the detector output, and I believe this was used, and again, I don't have an instruction manual for this, but I believe this is output for like if you wanted to have a signal meter or something like that. Correct me, guys, if any of you know this. I mean, I didn't look this up, so might be speaking out of turn on this. And then you have your two outputs, fixed and variable. The fixed just is a fixed signal level output. The variable allows you to use this potentiometer to kind of dial in the gain. So if you have a preamp that doesn't like the output, this is too high or too low, you can customize it by using this variable output. FM auto level and your muting level, you can actually set at which point you want all these automatic features to come in. Okay, so you can see your FM auto level will go from 30 to 50 dBF, and that's kind of the trip point for it. The muting level is where you can actually turn this way down, and that will make the muting very unsensitive. So like anything clear down to 20 dBF will unmute the muting circuit, any station that's that weak. This is set to midpoint, so anything around, this is 30 dBF, and then 40 is the maximum. So anything under a 30 dBF signal strength is going to trip the muting circuit and make it mute. Anything above that will trip it off. Sensor gain, this is actually how sensitive the little touch sensor is on the tuning knob, and I believe this same thing is on the TX9800. You can see a lot of the things on this receiver carried over to the TX9800, even though the 9800 wasn't as advanced as this in some ways. It didn't have the front end tuner portion that this one does, but it was a very good tuner also in its own right. It was excellent, almost as good as this. So let's take a look inside, and then we'll turn it on and see how it performs. Okay, here's a very rare opportunity to see something that not very many people get to see, and that's the inside of this F26 tuner. You can see how elegant this thing is and how simply laid out it is, and it's just, you can see they've really perfected things when they came to this one. When you look at how it's laid out, it's very simple. There's no funny looking encoders or any kind of thing like that. It's back to basics. It's just a very well designed, well executed tuner. And I'm not even going to try to attempt to tell you what all these are, because I don't have any information on this. I've never worked on one, and it's quite frankly much different than anything I've ever worked on. But when you see things like this parallel balanced linear detector, and you see this huge low-pass filter, these are the kinds of things you typically see in very high-end amateur radio equipment and so forth, quite frankly. You know, some of the ICOM and Yaesu and equipment like that, you look in, you know, in the Kenwoods, you see those kinds of things in them, and those can be thousands of dollars for one of those receivers or transceivers. This is just an FM stereo, and they spared no expense, and they executed it properly. It doesn't have any Rube Goldberg stuff like the F28. They really figured it out on this one. Now, I took a couple screws out so you could see the other thing that's kind of amazing, and that would be this tuning gang here. Look at that. And believe it or not, there are 1, 2, 3, 4, 5, 6, 7 gangs in this tuner, and you can see all the stages. And you can see over here, it's very similar to the F26 or the F28, where you have your first RF, you have your second RF amplifier, and then you have your mixer, and it uses a very similar layout. The main difference is the F28 has 6 gangs, and this one has, and then it has, for the 7th gang, it uses that weird VCO circuit with the Varicap diode and that synthesizer board and all that. That's gone now. They went back to basics. This 7th one is in here, just a standard tuning gang. So you can see there's no Varicaps. There's none of that stuff going on in this one. There may be a Varicap or a VCO in here. Obviously, there's some, but it's, you can see they went back to more of a basic design when they did this. And That's why I said this has a lot of similarities in some ways also to the TX 9800. So it's kind of like the technology that led them to the TX 9800 came from this, and the technology that led to this came from the TX or the F28. So you can see this is kind of the best of both worlds tuner. So yeah, this is it. So this is so rare and it's so old and it works so perfectly that I'm a little bit reluctant, even if the owner asks me to do so, I'm reluctant to even go so far as to recap it. Can a recap help it? Well, you know, these are older caps, and yeah, they probably could. I don't see anything leaking or anything physically. I'm sure some of these may have elevated ESR or whatever, but the tuner, to my ears, sounds really good. And because of its rarity, it may be worth keeping this thing all original, unless you're going to listen to it on a daily basis. If this was going to be something that you don't care about, you really care more about using it than you do about preserving it, then you probably would definitely want to have it go over the whole thing. But again, something like this, you may never see another one of these again, and if you do, it's going to be very rare. This has a little, the faceplate and everything's a little bit chewed up on this one. It definitely needs polishing it up and cleaned. It's got some dirt on it, but as you can tell inside, it's pristine. And it doesn't look like anybody has ever had this apart ever. We may be the first people to ever look inside this receiver since it was built. I really don't, the screws didn't feel like they were even ever opened. So this is a very good example. Even though the outside got dinged up, the insides are good. Let's put it back together and let's listen to it and let's see what it does. All right, we got this thing cleaned up, and the unfortunate thing is that you really can't appreciate the sound quality of this receiver. You know, you get a lot of comments on these FM tuners, why do you bother with them? There's no good FM stations out there anymore. And to a degree, that's right. But there are a couple channels in my area, at least, out of the Pittsburgh, Pennsylvania area, that are old classic stations that have been, in Pittsburgh for many, many years. And there's a couple that are very big, old, well-established stations, and they still actually have pretty high quality FM. But anyways, let's listen to it and see how it works. This thing is all automatic, and what you're going to find out is that even the wide and narrow IF is automatic. Stereo mono, automatic. Everything is automatic. The tuning will lock in, and you can even be a little bit off channel and it'll pull it in, just like on the TX 9800. And you're going to see as I tune this, if you look at my TX 9800 video, you're going to see very similar activity on this. So let's scan through the dial a little bit, and you're going to see the difference when you find a really strong station. This is going to kick into wideband, and it actually, you can really hear the stereo separation come in when you do that. Now on the microphone through YouTube, you're not going to hear that. I guess I could record a separate track and overdub it into the video, but I'm so booked with work, I don't have time to do that. But take my word for it. So, okay. And you can see we just got a strong station, and you can see the wide lit up. Let's get some lights turned off here. Make it a little easier to see. So you let go and it locks. And that's how this works.
Delicious veggies. Miracle Grow garden soil. 5 bags are just $10. All project looking like a whole snack. Green honey's in my safe.
And you can see it's a weaker channel, so it drops out of stereo.
Loved,
And of course, so do all the other tuners out there.
Guys necessarily on the team. Obviously, they're adapted.
You see the touch sensitive.
Film critic Justin Chang has this review.
And you have to realize, I don't really get very good reception where I'm at. There aren't very many FM stations close to me, and I'm down at the bottom of the hill, as I say over and over again. And you've noticed every little tiny bit, I'm picking up another station on this. This thing really, literally, without doing any fancy tests, it is noticeably more sensitive than a lot of the other receivers out there. But I'll bet you that if you compared the circuit design in this and the circuit design in the TX9800, you would see a lot of similarities. You will be able to tell that they're related, just how this thing reacts and how it works. So really, if you can't find one of these, which you probably can't, it's so rare, I would say a good second to this would be a TX9800. Or like I said, the F28 is a great receiver. It's just a lot more complex to achieve basically the same goal that this thing's doing. So